Tim Vicky. He will share about Monadic approach to Ruby error handling. Welcome, Yin Jiahui.
Hello. Okay. So, how are you today? Pretty good. Okay. Uh, I'm traveling here for weeks, and I also falling in love with Taiwan. So, uh, we have such a nice weather today for the conference. So, welcome everyone to Monadic approach to Ruby error handling. So, I think exception in Ruby is well known to all Ruby developers. It's a unique data structure representing error or unexpected condition in Ruby programs. So it's carry tracing, the type message, error message, the backtrack, and take a look at the code snippet here. So it shows the divide function. We try to handle the division by zero, quite common error. So when it's if the division by zero is attempted, Ruby raise an error. So I printed out if to see what showing on the console. And additionally, I also try to raise an additional error if the result is not expected. Then I divide by the console. Then it carry we can see clearly it's carry three type message backtrack, and this no exception. Let's dive into the hypothetical scenario. So imagine we are creating solution for the purchase ticket RubyConf. So today I have chosen the web application for text because it's familiar for the most and the concept are universal. I'm going to visualize high-level design system as the backbone for our web application. Start with user who interact with the front end and buying a ticket. The user journey is facilitated by front end, which get to Sky server. So we create an order crafted by using the user ID and the ticket ID. Order is we storing into the database, and lastly, we also integrate with the payment gateway for our monetization. Let's dive into the application. We want to build our block for our backend server. So we're just using the straightforward MVC architecture, like controller talk directly with the database and the payment gateway. We bypass the view component because we're focusing on the backend development now. So I come up with the naive implementation by putting everything in the controller. So the code may look a bit overwhelmed. So don't worry, I break it down and visualize for you. Firstly, we buy a ticket. We need two pieces of data: is the user ID and the ticket ID. Then we search for a corresponding user and the ticket. So if it's search if we found, then we create an order with even user and ticket. Next, we check the user balance against the order price. If the balance is enough, so the transaction is continued. Then the controller interact with our payment gateway to initiate the payment submission. This is where we integrate the external service to proceed the payment. Upon the successful submission, we confirm purchase by rendering the successful response to the user. Next, we handling three main value point is the user balance, record retrieval, and payment submission. So if the user balance is small, we rendering the instant balance to the user. We cut the report not found to the file. We use the file method in the and the ticket. And similarly for the order create, we use the bank method there. So we also catch the record event exception. This quite a traditional way when we handling in Ruby. And finally, we if the payment mission falls, so we also cause the exception. So in every step, if something don't go as planned, like we ensure we inform the user the clear error message, right? So what do you have any comment for naive? So is chaotic, is error prone, not easily to extendable, hard to read, and it's not reusable. So can we make it better? So before dive into the talk, I do myself. My name is Huy Yu. My name in Vietnamese is Yu Ya Huy. So I'm a backend engineer with 5 years experience developing high traffic web application. So I'm working in Singapore and I'm also speaking at RubyConf Thailand this year, and finally I'm right here in the RubyConf Taiwan. So I'm a software engineer at RubyConftw. So we are build the system that deliver agent content to the million users over the world on the daily basis. So RubyConftw, the world leading platform for agent entertainment and the culture, where millions discover and consume their prime time of show and the movie. And of course, we also subtitled in more than 300 languages by the community. So let's start. What is the programming? It's about a crafting solution through the set of instruction, and we give it to the computer. In short, it's just solving the problem. So our job as software engineer, we just solving the problem every day. So and I believe everybody is familiar with the mathematical concept that is the fx equals y. So let's break this down. So here the f is represent our solution. X is our like data parameter our program to execute the logic. Y is the expected output, the result we anticipate function when is executed correctly with the given input. Right. So what's our error? With the mathematical conception analogy here, we execute the function x with specific input x. Ideally, we want to the output is outlined with our prediction we already predicted. But however, the output is different with the y, then that's how we call it error. So, software error is unexpected result we get when the program does not work as planned. Instead of getting y as we expected, we're getting z or something else. So in the broader term, we can categorize the software error into the two main types. So first one is the expected error, is our part of program execution. So they aren't surprises, but rather the scenario we have to prepare and predict when do the normal operation of our program. So as a software engineer, it's our job to anticipate their errors. So we need to think ahead about what might go wrong or have a measure in place to handle their situation when it happens in our production environment. So example, like in our example, we design a sales ticket. So our expected error is in the business logic, maybe it sold out or the purchase cannot proceed after the midnight due to the phase restriction. And error also stemming from the external dependency as well, like it could be simple as using wrong library usage. It can complex dealing with the networking space installability on the server downtime. And understand planning for this expected error is a crucial part of our software engineering. On the other hand, expected error is yeah, that is not that is unexpected error. Yeah. So usually they commonly refer as bugs or defects. By nature, it's not predicted by developer. And beyond of our code, like there any factor is not outside of our control. We issue like the database corrupted or we run out of memory. And though problem is typically is associated with the infrastructure, so we can't always predict it when they happen, but we can mitigate them by diligent monitoring, improve our software observability. So in this talk, we only focus on the expected error and we do it well. By mastering the expected error first, then we can ourselves to have ability to better address the unexpected error and later on it's many things in our daily software engineering. So our goal is like create a robust system that minimize the disruption and prevent incident in our. So just quick remind our problem here. As a user, we want to buy the application component. And coming to improve the naive implementation, I introduce the logic layer. So this layer acts as the brain for our application. It's encapsulating the core function and the decision. So instead of orchestrating the request through the controller, now we have the business logic layer to perform it. And so why this approach is benefit for our application? So essentially our business rule is making our system more maintainable and adaptable to future change. It simplifies our unit static by isolating business rule and the rest part of our application. To attend the it's also attend the reusability, like we not only using as the web server, we may integrate with the message stream platform, like where we starting point our is not from the controller, it's from the message queue, for example. So this bit logic layer is quite helpful for our application. So coming to refactoring version 1 for our implementation. Literally, like we handle multiple responsibility in line within the controller. So and this, like I take a step to modularization and using the business layer. So first move is I wrapping the creation order into the separate service. Next is the payments mission into the checkout order. So though encapsulation is ensuring our controller remains clean and our code is more maintainable. Is the controller after we create order, we wrap it to create order and checkout services. The flow is still the same. User by the ticket, and instead of now we in line handling everything in the code we handle inside the service. Though exception part in the controller. And then relevant error message will return to the user. So the difference between the naive implementation and this one, you can see now the error is in the first one we go into the sample, then we handle the error in the early return order, but now it's clear. So if maintainer come into it, it will have a less error prone when we handle and we understand what is the previous maintainer code. So after order successfully created, we continue to check our order. And the logic still says nothing changed, is insufficient balance and payment submission error, and we still return rendering error to end user, and at the end we render the full response. So what is the command for refactor v1? As we recognize is the significant improvement for the code flow and the readability. Though its enhancement is make less error, but still have something we didn't address is stability is remain limited, and the encapsulation is not robust. It would be like because the controller know many things about the service, right? And as a result, the review of our code is not really well. So, can we improve further? So now, when we improve it, we want the code is not just clean and readable. We also want it to flexible and reusable, and also encapsulate across different parts of our services. So coming to the refactoring v2, like aim to improve our business logic by encapsulating the error handling inside. So instead of handling it in the controller, we move it inside. Same for the our order. Yeah. This approach is not only clarify outcome of these services, and we also streamline our error management, error handling inside the services. And so in the controller is instead of handling many multiple exception in line, like for now we just focusing on the routing the outcome. And you can see the controller now just checking for spectral value to catching the error. With the change, we simplify our controller logic, making our code clear, and error handling is a lot better compared to the naive implementation. But there still be a problem with is the version 3 of this controller is now for efficient compared to naive. Yeah, so really easy to understand the version 1, but then easier like because when we do the software development, it's not we are not only solo deliver, like not solo developer, we collaborate with the team. So with the team, like we have many team members working on the same thing. We also have like different kind of mindset, different kind of approach to resolve a problem. So if we have the inconsistent value return or inconsistent like handling how we handle error, actually we may have a conflict between the team member because the pattern is somehow like a religion. So and also we didn't address is the controller still need to know about special value of inside of the services to be handle the error and return to the user. So it's quite leaky error detail. So how to resolve all the remaining problems? The answer is we return the monad at the result. So by returning a monad, we standardize our error handling across our software, ensuring the consistency and clarity of every outcome. So what is monad? Monads are the structure that encapsulate the result of the function and manage them in the predictable. They align the container. They holding the either success or an error, and they define how we can safely handle those results. Monad allow us to know complexity of error handling the straightforward way, like binary outcome, like either success or the failure. This simplicity is the key creating a clean and maintainable error handling. And next, we want the monad result is encapsulate two distinct outcomes. First one is success, and it carry a value or a value, so it's accompanied with the error. So this binary approach simplify our handling of function result through our application. So how do we this is how we can represent the monad result in our Ruby program. So we just wrap it with the open struct, and it's give us a simple way to define a success or failure step using two attributes is the successful or the failure. So successful carry the actual result, while failure carry the error detail, by both using same structure and the consistency. So with this approach, we can handle error-prone operation functionally and clearly. And we also need to know about the object. So what is the service object? Is the Ruby object is trying to execute one single action in the business logic, and we do it well. And it's also centralize our set of operation, like whether it's the validation, calculation, or any process that critical for our software functionality. It provides a well-defined, well-reusable API for other part of Ruby application. And this is the example. Okay, is just showing entire create order, and this is how we using it. So monadic approach is represent a powerful combination between the service object and the monad result in our application. So it's a strategy for leverage of service object and perform the business logic, and coupled with the clarity of monad result to communicate with the output. By returning monad result from the object, we create a resilient system and gracefully handle both the success and the failure state. So in a sense, monad handling about for cleaner, more maintainable, and by making handling of different distribution part of our software. And we can create a base class. So I call it like a monadic service or other service we want to encapsulate with this approach. So we create a base class with the monad result here. And because we only perform the single action for the business logic, so we want to wrap it in inside a call. And when the outcome is set, we call the set method, and we return the set monad result. And same for the value, we return to wrapping the arrow. Then with the refactoring V2, and we now applying to monadic handling, like we have to inherit monadic service. And you can see the order and the error message here. Wrap it into the set value. Same for the checkout order. We do the same, and returning sufficient balance, which the controller or the caller needs to know about this error. Now we wrap it into the value, and it's just one type of response. So the caller don't need to know too much about what we did inside the revoker. And finally, we apply it to the controller. And we can see the decision tree now. It's a lot better now. It just simplify our flow and really clear. So that is how handling approach we want to apply our application. And so the example is it's just some simple example. The real world use case, like have many things, like when we integrate into our production environment, and you can see like we need user authentication, check the ticket available, user validation. Then we select the payment method for validation, like credit card or anything. And you can see the red one is our value point. So the strength of Monadic handling is we can simplify this multiple value point with a simple manner compared to the exception. So Monadic handling is provide a standardized and consistent way for error handling. It's explicit and reduce the complexity of multiple value points. Our code more robust and maintainable, and completely encapsulating and reusable everywhere. So we also have some Monadic handling gems. So first one is the steampunk. It's written by Ted. It's sitting right here. And the next one is the also really famous. I think the most famous for now is dry monad. And I think Team also has some review of that as well. So we want to explore the error handling in the other term is in the followed mathematics analogy I showed you in the beginning. So the input x is we have to ensure is meet our validity for the function x to process. Right? If we can think this as a key of we unlock our solution. It's maybe in the right shape or the size, or the mechanism won't work when with the invalid input. So with the solution is we decide to take our valid input and predict the expected output with the y, and we have to make it well executed. So error handling is just ensuring valid input and predictable output. Then we come into the concept of validity and execution. So with the validity error, we can the business rule for the input does not meet the requirement to perform the operation, or the input does not conform the valid criteria for the problem. And the execution error is the when is unexpected, or it make our application crashing or perform undefined behavior. So in error handling, like distinguish between the validity and the execution error is crucial. Like our error handling is simplify, and we understand it better, and we address and minimize the disruption in our software development. So compared to the monadic and the traditional exception error handling, monadic approach is where its strength is in the validity error. It's leverage our encapsulation to manage the predictable issue with the input data. It provides a structured way of our flow from one state to the other. So our error are handled with the expected value. And on the other hand, traditional approach is reflective execution error. It's focusing more on the unexpected issue during the operation phase. Using mechanism like raising exception, like we normally using for Ruby. And this two approach is not mutual exclusive. Like in a talk in Thailand, like after I represent this, and some developer is reaching, and he asking me like whether I forgot about the traditional way and just using monadic way, and I answer is it's not being mutual exclusive. Like we need to tie those together. It's not like just you one it. And so before we raising exception, three questions we need to ask for exception outside of validity. Is action truly unexpected? Am I going to group the execution flow? Will I throw my heart when the exception happen in the process? So when you address it correctly, like correct way of error handling will stop your lifespan for a couple of seconds. It happens all the time. Then wrap up. So through this talk, we definitely have new strategy for error handling, and we understand different type of error in the software application. We understand how exception in Ruby and we create a boundary for the business logic layer, and we encapsulate it through the service object using wrapping. And we also use the monadic error handling by scatter object and the monad result. And we instead of praying, you need a monadic handling for your. That's all for me. Thank you.
Thank you so much for your sharing. Do you have any question for Hui? Oh, thank you.
I just want to ask like your arrow. So like it's okay, but then like an arrow with the same name, but it's not like so how do you
So because we combine the service object and the monad result, right? So when we call the caller calling to one service to perform the action and turn the error, we need to handle the error right there before we always passing error into the next caller, the previous caller before. So we always have this type of error, like exactly error we want to get that result. Yeah.
sorry not we have this like like we have this service object next together and service object can return sometimes and those arrow can be the same. For example, like take out like balance
Yeah, I understand your the good question. So I think to resolve that, we for the error like I showed earlier, like we have to type error. Is one is expect. So usually the expect is validity from validity error. It's put in the user mistake. For the user mistake, when we return error, we can let the user know, oh, you are making mistake. You can retry by yourself. Execution error, in the other hand, is the not the user, like they pushing the request with the valid input, somehow perform it in the wrong way. So in that case, like we should considering like exception to raise an error immediately, and we need to handle it immediately. Like there are two types of handling we need to address those errors. And all the different error, like let's say the insufficient balance in service A and that same error in the service B. Like if we really want to differentiate between those errors, we need to specify it, like identify it in the different error, patch it in the column if we want to go in that way. Clarify our error. And just hey, like in some critical error, like we need to use the exception to handle it, raising it, and we can do the factory. Okay. Validity error is we don't need to do the like it's just 400 requests all, and later on like for 400 requests is my end, like usually I just put some observability 400 error, for example, because that is the error from the user. But if the amount of this error showing in production is quite abnormal, then I need to raise it and coming to identify why running with the abnormal result.
Thank you for your question. Thank you for your answer. Anyone have a question for him?
Thanks for the talk. I have a question. In particularly in Ruby, I feel it's really easy to implement my own ad hoc either or maybe Monad and just start using that. Do you always reach out for properly implemented Monad classes like those gem, or do you at some point switch to the proper implementation? And if that's the case, what are the things you see as the need to switch to proper Monad implementation from ad hoc?
Ad hoc you mean is the exception?
Oh no, like make your like I've implemented very simple maybe or option in Ruby many times before, and I'm wondering if you always reach out for the proper implementation. You start with like a really simple, naive implementation in your code.
Yeah. Okay, so actually it depends on business logic of our application. Like for Rails, usually like we ignore the like endpoint, the delivery of endpoint server part. Like we only focusing on business logic, and usually for the web have the complex business logic, like it's where the monadic error plays a vital role for reason. For like simple application, like we not really complexity, so we just like using the normal one. Like this one is only we solve the complexity of people point of value, or like, let's say we have a complex application, and when the new one we also need maintainer coming to read the code and understand easily, and so we can maintain data moderate to read the code and make it.
Okay, thank you.
Thank you so much. Thank you for your question. And that will be our last question. Thank you so much for your sharing, Hui. Okay, so I think everyone hungry now. Is it our lunch time? So we can have a break until 1:30. We're gonna start our afternoon session. Thank you so much.